Hello? Hello, can you able to hear me?
Yes, sir.
Yeah, good. Okay, right. So good morning. So we'll just start with a new chapter. Okay. Now, please just somebody confirm me whether you have got the PPT on your screen. Have you got the PPT on your screen?
Yes, sir.
Yeah. Okay. Right. Right. Once again, good morning, everybody. So we'll just start with basically this chapter is dedicated to CNC programming. Okay. Initially thought I want to do this on the blackboard, okay, so that I can able to explain very clearly the concepts. So let us as we could not able to get that opportunity, now I'm just taking this chapter now. Okay. Right. Now this chapter is along with your robot technology. Now robot technology is what we have done already. Okay. Now we'll just go with what is called as the computer numerical control, okay, which we generally call it as CNC. Okay. Now, if you understand the basic concept of the advanced manufacturing system, the basic concept of advanced manufacturing system has got the larger of the achievements by using what is called as your the CAD and CAM system. Okay. So basically, the CAD and CAM system is going to be considered as one of the important terminology in order to get the benefits of what is called as the numerical control. Okay. So first, we'll try to understand what do you mean by numerical control. Okay. So before we go to numerical control, now in order to produce the component, previously what we used to do. Okay. Previously, we are going to do manually. That is known to us. That is, a conventional machining was carried out. Okay. By basically a human labor is going to control the machine and he is going to carry out the operation. But later stage, there is an improvement and a new technology which has come, which we call it as numerical control, or we simply call it as NC. Okay, that is NC machine. Okay. Now, what is numerical control? Okay, as the name indicates, a numerical control is a form of programmable automation. That means we are going to write the program. Okay, how the programs are going to be? The programs are going to be written by using what are called as the numbers, letters, and symbols. Okay, that is very, very important. Okay, right. Now the programs are going to be written by using the numbers, by using letters, and by using symbols. Okay, now this is basically called as your the NC programs all about. Okay. Now this alphabets or numerical, what we call it as the alphanumeric data. Okay. What it indicates generally, it indicates what is called as if the work part is going to be there here, and if the tool is going to be there. Let's we call it as this as the tool. Okay. Right. And this is the workpiece. Right. Now basically this tells about okay the movement of the tool. Okay, the movement of the tool with reference to the work part. Okay, basically the program is going to represent the relative motions, the relative positions between the work head, okay, and the work part. Work head is nothing but your the cutting tool. Work head is nothing but your cutting tool. Work part is nothing but your this. Okay. Now the movement of this and this, the movement of the tool with respect to the work part is going to be present in the program. Okay. And that program is going to be written by using what is called as the numbers, letters, and symbols. Okay, that was your numerical control. Okay. Now, in this numerical control, what we are going to use is we'll be having what is called as a magnetic tape. Okay, now something like this. Okay, so this is the general observation of a magnetic tape. Now, in the magnetic tape, there are going to be what are going to be called as the holes which are going to be present. Okay, just assume there are something called the holes which are going to be present. So this indicates the first line of the program, second line of the program, third line of the program, the fourth one, the fifth, like that. The depending upon the number of length of the program, okay, we will be having the punched tape. This is called as a tape. Okay, so this is a paper tape or a magnetic tape. Now, once we are going to write the program, assume that 4-line program we have wrote. Okay, so it's a 4-line program. Then what is that I am going to do? I am going to punch this. Okay, please understand. I am going to punch this according to the type of the program. Okay, so this was earlier case. Please understand. This is not at all used now. Okay, just to make you to understand how it is present previously. So we are using what is called the punched tape. Okay, so in this punched tape, there were number of holes are going to be present. Okay. Now we are going to punch these holes depending upon the program coding. Okay, depending upon the coding, I am going to punch this, and this is going to be fed to, okay, this will be fed to, okay, what is called as your the machine control unit, okay, which is called as MCU. MCU is machine control unit. Then machine control unit is going to read this, okay, machine control unit is going to read the program one by line and gives the command to what is called as the machine tool. Okay, now this is what is the procedure which is going to occur. That is, from magnetic tape, program will be inputted to the magnetic tape by through punching the corresponding holes. That punched tape will be read by machine control unit line by line, and machine control unit is going to give a motion to what is called as a machine tool, and machine tool will appropriately do the operation. Okay, that is what is the case. Now the major problem of this method is going to be the tape whatever we are going to use is very fragile. Okay, so as it is very fragile, generally always there is a problem of what is called as the loss of data is going to occur. Many mistakes are going to occur. Therefore, now this method was very lesser used. And also understand, NC machines are generally called as the hardwired machines. Okay, now basically the NC is going to be a hardwired machine. So this is the problem. Okay, now the problem is what? The problem is the program inputting is going to be difficult. Okay, now in order to avoid this, we have started with a new technology called as the computerized numerical control. Earlier, what we had what is called as numerical control machine, NC machine. We had NC machine. So NC machine is more or less, it is going to be a hardwired system. Okay, and the major problem is with the punched tape. Okay, now with the development of the technology, the systems have come into picture. Means the computer has started to evolve. Okay, once the computer has started to evolve, now we are going to use the computer. Okay, now if you are going to replace the magnetic tape by using a computer, that method is what is called, the technology is, we generally call it as computerized or computer numerical control. Okay, just observe, CNC is nothing but a NC system. Okay, so CNC and NC, now NC is not at all present. Okay, NC is obsolete now. Okay, NC is completely obsolete. Now we use only a term called as CNC. Okay, even if you use NC, it just means it is CNC only. Okay, now what is CNC? So in case of CNC, that is computerized numerical control, is an NC system. Okay, what it utilizes? Okay, it utilizes, very important, it utilizes a dedicated stored program computer to perform all the basic NC functions. Okay, now earlier we used to do by using hardwired methodology. Now in the case of what is called as your the CNC, we are going to use what is called as the softwired NC. Basically, CNC is termed as what is called as softwired NC, just because that we are going to use the computer. Now here, what type of computers we are going to use? That is the machine control unit, whatever I told, is based on a dedicated microcomputers, okay, rather than hardwired controller. Remember, if you use a hardwired controller, it is called as NC machine. Okay, now you replace this hardwired controller by a dedicated microcomputer, and thus that is what we call it as the CNC. Now, if you observe a simple the configuration of a CNC, it looks something like this. Okay, first what we have what is called as the program entry. Okay, now this program tape reader is for NC. Okay, now you just remove this. Okay, you have initial program entry. Where are you going to enter the or enter the program? The programs is going to be entered to the computer. What is that computer by name? It is either a mini computer or a micro computer. Okay, right. So you are going to input to a mini computer or microcomputer, and you have what is called as a machine tool, and we have what is called computer hardware interface. Okay, now you have, this is a computer and this is going to be your hardware device. Now this will try to connect from the microcomputer, which is a computer, and a machine tool, which is a hardware. Okay, now this communicates between this and carry out the operation. Okay, now that is something related to what is called as the concept of the computerized numerical control. Okay, right. So that's a basic understanding of CNC all about. Okay, right. Now, what are the different features of CNC system? Because it's very important. Might be asked for some 4 to 6 marks. Okay, right. Now, what are the features? Okay, the features are going to be, now if you can observe, storage of more than one particular program. Okay, now that is very, very important. Okay, now what you can have is you can have, okay, right, storage of more than one part program. Okay, what does it mean? Now, earlier, what is going to happen? If you are going to use a punched tape, it is one punched tape, one program. That's all. Okay, are you understanding? One punched tape will be used for only one program. Now, in CNC, what is that we are using? As we are going to use the computer, remember, okay, we are going to use what? We are going to use the computer to carry out the operation. As we are going to use the computer, that is program entry is going to be to the computer. Okay, therefore, it is possible for us to store more than one part program. Okay, part program is nothing but a particular instruction. Okay, right. Then various forms of program input. Okay, how you can input the program to the computer? You can input the program by using what is called as you know, okay, the general. Okay, so you can input the program by using the manual keyboard, or you can use what is called as the external devices. Okay, you can use the external devices. Okay, or you can use what is called as the joystick. Okay, in order to input the thing. Means the various different forms of program input is going to be present. Okay, and program editing at the machine tool. Okay, if you observe the CNC machine, so if the machine is going to present something like here, okay, by the side of the CNC machine, you have one particular panel is going to be present. Okay, if you are aware. Okay, so you have what is called as a panel which is going to be there. Okay, now after you input the program to the system, okay, through this panel, you can change the program. That is, editing of the program is going to be possible. Okay, the editing of the program is possible by using what is called as this CNC machine, which it allows. Okay, right. Then we have what is called as fixed cycles and programming subroutines. Okay, this is very important. Now, what do you mean by fixed cycles and programming subroutine? Now, in order to do repetitive operations, okay, in order to do this and this is same. Okay, so it is fixed cycle and canned cycle, both are same. Okay, right. Now, the fixed cycle and canned cycles are nothing but in order to do repetitive operation. That means, let's assume that you have a plate which is going to be present. Okay, right, and you have to drill a hole like here. Now, at all the plus location, okay, wherever I am marking as place, at all the plus location, you need to drill a hole. Now, what is that operation? What you are having? The only operation what you are having here is what is called as the drilling. Okay. Now, whenever you want to do repetitive operation, okay, if you want to do repetitive operation, you can use what is called as the programming subroutines or what is called as the canned cycle or the fixed cycles. Okay, now if you call these canned cycles or the fixed cycle, they are going to come and carry out the operation and finish it faster. Okay, so that is the advantage of this. Okay, right. Then information about machine utilization. Okay, so the CNC is going to be mainly used, okay, so that you can utilize or you can do the work at a faster rate. That is, machine utilization is going to be larger. Okay, so communication interface. So as you observed here, okay, now the CNC is going to interface between your machine tool and what is called the computer. That is the thing. And then diagnostics. Okay, diagnostics is nothing but basically about checking the health of the machinery. Okay, right. Positioning features are going to be there, and this is very, very important. Proving of part program. Okay, what do you mean by proving of part program? Now, just observe carefully. Proving of part program means now you have done the program now. Okay, now once you have done the program, you are not going to directly run on the machine. Okay, if you directly run on the machine, if some problems are going to occur, okay, if some problems are going to occur, then the material loss is going to be there and the machine might be at risk. Therefore, what you are going to do after the program has been done, you will load it onto this control panel and run through the control. We have a software here, and you can able to observe the simulation. Very important. Please understand. You can able to observe what is called as the simulation. Okay, how the actual machining is going to occur. Okay, through the software. So you have CAD/M software. Okay, CNC softwares are there. Okay, right. So MCAD, something like that. Okay, right. There are plenty of software which are there, which are simulation softwares are available, which says about what is called as the concept of the machining. Okay, so that is the case of what is called as the proving the part program. Means after observing the simulation, what you do is if the simulation is proper, then you are going to actually carry out the work on the machine. Okay, so that is the concept of the proving of part program before actually running. Okay, so this is what is generally called as, if you are aware, so this is called as what is called as dry running. Okay, so please remember this word. Okay, this is called as what is called as dry running. Okay, dry running is going to be done not on the machine by using what are going to be called as the software. Okay, by using the CAD-M or MCAM or something, or some different softwares are available. By using those software, you are going to carry out the proving of the part program. Okay, so these are the important things which are present in what is called as your CNC machines. Okay, right. Now we'll try to briefly go with what are the components of CNC. Very simple thing. Okay, what are the components of CNC? Is we have what is called as only three components. One is your the program. The program is the list of instructions. Very simple. The program is nothing but the list of instructions which is going to be required in order to carry out the operation. Okay, right, right. Okay, are you all there? Okay, can you able to understand? Hello, hello.
Yes, sir.
Yeah, okay, right. So now program is nothing but the list of instructions. Okay, now what is that instruction is going to be? The instruction indicates the various different operations to be carried out. Okay, means now you have the different lines. Okay, so all this I'm going to explain, don't worry. Okay, so you have different lines: first line, second line, third, fourth, fifth line. Okay, so this is called as the instructions. Okay, this is called as a program. So each line is called as what is called as the instructions. Okay, so program is nothing but it's a set of instruction. Okay, what this program consists of? Okay, this program consists of what are all the activities to be carried out. Okay, so what are all the activities to be carried out is present in this particular program. Okay, now by using what are called as the letters. Okay, by using the letters. Okay, by using the numbers. Okay, and by using the symbols. Okay, so right. Now by using this, okay, you are going to write the program. Okay, now that is the first part. Okay, once the program has been done, then you input this program into the heart of the CNC is what is called as your MCU, which is called as machine control unit. Very important. Okay, so machine control unit is the interfacing member. Okay, machine control unit is the interfacing member between the program and what is called as the processing equipment. Okay, very important. Okay, right. So basically, what is machine control unit? Generally, the machine control unit is nothing but the microcomputers. Okay, the machine control unit is nothing but the microcomputers or the mini computers which is going to be present. Okay, now because of this machine control unit only, we are going to call that by a name called as the computerized numerical control. Okay, so please understand. So the MCU is nothing but the interfacing member, which is the one which executes the instruction. Okay, remember, which executes the instructions line by line. Okay, this one understands the program line by line and fed to the machine control machine, fed to the machine tool in order to carry out the operation. Okay, now this is the basic understanding of what is called as the machine control unit all about. Okay, now which is the one which actually does the process, does the work is important. The one which does the work is called the processing equipment, or what is called as a machine tool. Okay, right. This machine tool will understands the program line by line, and it makes sure that it moves. The tool is going to move as per the instruction, and the work is going to be carried out. Okay, now you have a program. Okay, the program is read by MCU, and MCU instructs the machine tool to carry out the operation as per the instructions given from the program. Okay, this is the basic three elements of a program. Okay, right. Now next we'll just go with an important one called as classification of CNC system. Okay, right. Now how the classification is going to be? Now there are four different headings. Okay, so the classification of CNC system is based on feedback control. Okay, based on feedback control is one, based on motion control system, based on the number of axes, based on the input power supply. Okay, so once the classification is going to be asked, okay, you have to write all these classification. Okay, they may ask individually, okay, or they may ask in a, or they may simply ask the classification of CNC system. Okay, if they simply ask classification of CNC system, then we have to write all these 4 classifications. Okay, right. Now we'll just go one by one. Okay, right. So based on the feedback control. Okay, right. Now what do you mean by feedback control? Okay, is important. Okay, right. Can you just say something about what do you mean by feedback? Can anybody say what do you mean by feedback? Hello? Can anybody say what do you mean by feedback? Anil Kumar? Anil? Can anybody say what do you mean by feedback control system? Right. Now, in case of what is called a CNC, we have what is called as based on feedback control, the first one. Okay. Now, in feedback control system, we have 2 different types. One is called as open loop control system. Other one is called as the closed loop control system. Okay. Right. Now, very simple. In case of open loop control system, no feedback, okay, is going to be taken. Okay. In case of open loop control system, no feedback to verify that the actual position achieved is the desired position. Okay, what do you mean by this? Okay, so no feedback. Okay, let me explain this. Okay, now just observe, this is the open loop control system. Now what we have is we have a stepping motor or a stepper motor, we have a lead screw. Okay, now work table has to be moved. Okay, now assume that I have given a command to move the work table by an amount equal to x by an amount equal to 20 millimeter. Okay, just assume. Okay, now I have given the motion to the motor. The motor will in turn rotates the lead screw, okay, by which the work table is going to, the work table was here, let's assume the work table is here, then the work table is going to move to this particular distance. Okay, right. Now this movement has happened because of what? This movement has happened because of the command what I have given. I have told X, I have told the work table to move by an amount equal to 20 mm. Okay, the movement has occurred. Now the question is whether the work table has exactly moved by an amount equal to 20 mm. Okay, now that is a question. Okay, if you are going to verify, let's say, let's put it in this way, open loop control system, there is no feedback, means to say I will not going to verify whether the work table has moved to the desired location. I have told 20. Okay, whether it has moved to 20 or whether moved to 22 millimeter or whether it has moved to 18 mm, I am not going to worry in case of open loop control system. Okay, that is what is very important. Okay, so open loop control system operates without verifying, okay, that the actual position achieved in the move is the desired position. Okay, desired position is how much? Desired position is 20 millimeter. Okay, what is the actual position that I expect it to be? 20 millimeter. Okay, now in this case of open loop control system, I am not going to measure whether it has actually reached 20 millimeter or not. Okay, that is a case of open loop control system. But on the contrary, in case of closed loop control system, now what we use, we are going to measure. In order to measure, we use what are called as the feedback measurement. Okay, we are going to measure by using measuring instrument, and that feedback will be taken back, okay, to confirm whether the final position what you achieved is going to be the intended position. Okay, so that is what is called as the case of the closed loop control system. Okay, right. Observe. Now in closed loop control system, okay, as I have mentioned, now the similar everything is going to be there. Now just observe, the lead screw has moved. Okay, there is a motor over here. Okay, the motor over here, it makes the lead screw to move, and as the lead screw is attached to the work table is going to move. Okay, now how much it has moved, how much the work table has moved is going to be sensed by a device called as an optical encoder. Okay, now this optical encoder, okay, this optical encoder, okay, is going to give the motion. Okay, now this optical encoder is going to measure, okay, what is the amount of movement of the work table and it will give a motion to this comparator. Now this comparator, this fellow will compare. Okay, how much it has, what is the input given? The input given is how much? The input given is 20. Okay, now I'm going to measure the output. Okay, now the output is going to be measured and compared with this. Okay, if there is any error, appropriately it is going to be adjusted to make sure that always the movement is going to be the exact one. Okay, now if you are not going to use a closed loop control system, it is not possible for you to understand whether you are moved to the required point or not. Okay, so this is a very important one. Okay, next. The second classification is based on the motion control system. Okay, in case of motion control system, okay, that is second classification. We have three methods. One is called as PTP motion. Okay, that is point to point motion. PTP is nothing but point to point motion. Then second one is called as straight cut motion. Third one is the contouring motion. Okay. Now we'll try to understand what is this the motion all about. Okay, right. The first one is called as your PTP motion. Okay, in case of PTP motion is also called as the positioning system. Okay, it's also called as the positioning system. Okay, now understand carefully. Okay, so PTP motion is called as what is called as positioning system. Okay, what is that you are doing? The tool is going to, okay, the tool is going to position at a particular location. Please understand, the tool is going to be positioned at a particular location and work will be carried out at this particular point. Then again tool will be positioned to some other location and work will be carried out. Remember, when the tool moves from first position to second position, there will not be any operation performed. Please observe carefully. Point to point means the tool is going to be moved from one point. It reaches to point number one, it does the operation. Then after that, I will move the tool to the second point. After reaching to second point, it does some operation. Then it moves to point number three and it does the operation. Okay, now this is called as point to point motion. Okay, now you know very clearly the type of operation which require this PTP motion is what is called as your the drilling. Okay, all drilling related operation, because you are going to carry out the drilling at a particular position. Okay, right? So all drilling related operation, okay, all drilling related operation is going to be, okay, all drilling related operation is going to be done by using what is called as PTP motion. Okay, drilling, reaming, counter boring, counter sinking, all the type of tapping, okay, boring, all that operation is going to be done by using the PTP motion. Okay, then the second one is called as the straight cut motion. Okay, now in case of straight cut motion, observe the cutting tool. Okay, now this is the cutting tool. The cutting tool is going to move either parallel to one direction. Now here it is moving. Now this one is what? This movement is parallel to x direction. The cutting tool is going to move in one direction, which is either parallel to x or parallel to y. Now this is moving like this, and it can move in this fashion, which is nothing but parallel to y direction. Okay, it is. Now observe tool path operations performed during tool motion parallel to x or y axis. Okay, now if you observe carefully, okay, now in case of your the turning, let's take an example of a turning. Okay, now I want to remove this portion. Okay, I want to remove this portion. Okay, right. Now how are you going to move the tool? Now the tool is going to be moved what? The tool is going to be moved parallel to one particular axis. Okay, when the tool moved parallel to one particular axis, so the diameter of which is going to be reduced. Okay, so that is one type of straight cut motion. Okay, other straight cut motion is what? I want to reduce the length of the work part. Okay, I want to remove this portion. Okay, I want to remove this portion. Okay, what is this operation is called as? We know this operation is what is called as the facing operation. Okay, correct. Okay, facing operation. Now in facing operation, how the tool is going to be moved? The tool is going to be moved perpendicularly. Correct. The tool is going to move like this. Okay, the tool is going to move perpendicularly, by which the length of the tool is going to be reduced. Okay, now this is a case of drilling operation. So this is a case of plane turning. Remember, plane turning. Okay, the turning, you are only reducing the diameter of the work part. Here you are only reducing the length of the work part. That is called as straight cut motion. Okay, now you should understand at this point of time that the motion of the tool will not always going to be Understand? The motion of the tool will not always going to be parallel to one of the axes. Okay. I may have to move. I may have to move what? I may have to move in an inclined direction. Okay. Understand? I may have to move in an inclined direction. If I want to move in inclined direction, okay, how the tool has to be? The tool has to move across both x and y direction. Is it not? Okay. The tool has to move both across the x and y direction parallelly. Okay. Right. So simultaneously, I have to move in x direction and also y direction. If I move only in x direction, it is horizontal movement. If I move only in y direction, it is vertical movement. If I want to do at an angle, both x movement and y movement should be given. Okay. So that type of motion control system is what is called as contouring motion. Okay. Right. Now observe. Okay. In contouring motion, just observe. What is this movement is all about? Right. Now this movement from here to here. Okay. Now here to here is going to be straight cut motion only. Please understand, because I am moving the tool parallel to x-axis, straight cut motion. I have reached here now. Okay. Now the tool has reached this particular point. Now from here to here, I want to move. Okay. If I want to move from here to here, if I use contouring motion, sorry, if I use straight cut motion, the movement is going to be like this. The movement is going to be like this. Correct? Okay. Or if I use the other motion, okay, the movement is going to be vertically like this. Okay. But I don't want this also, and I don't want this also. Okay. I want the tool to move in a curvilinear fashion. Okay. If I want to make the tool to move in a curvilinear fashion, remember the tool has to move simultaneously both in x-axis and also in the y-axis. Okay, therefore this is what is called as contouring motion. Now it has come here. Okay, now from here to here I have to move. Okay, now if I want to move from here to here, then again straight line only. Okay, it is a straight line only, but both the direction. Okay, so it has to move in both x and y. Therefore this is called as your contouring motion. This is again a contouring motion, both x and y. Okay, both x and y is going to be required. Okay, now this movement is what is called as a contouring motion. Generally in case of the machining, all the time, okay, most likely we are going to use the contouring motion. Remember, okay. In case of PTP, very simple. In case of PTP, you go to a particular point and you carry out the operation. Okay. Then again move to another point and there you carry out the operation. Okay. In case of straight cut motion, you are going to move the tool parallel to x or parallel to another axis. Okay. Right. Simultaneous movement is not allowed. Now, when you go to contouring motion, the simultaneous movement of both x and y is going to be allowed, by which you can make the tool to move at certain angles. Remember, if you want to make the tool to move at certain angle, you have to give a motion to both the axes. Okay, and also if you want to give a rotation, a curvilinear motion, again you have to give a motion to both the axes. That is called as your contouring motion. That is very, very important. Okay, right. So these two are very, very important classification. Okay, then we have next called as classification based on number of axes. Okay, how many axes are going to be present? Okay, right. Now broadly we have what is called as 2-axis CNC machines. Okay, so what is 2-axis CNC machine? So if you observe 2-axis CNC machine, so the example is going to be what is called as your lathe. Okay, right. Just observe, this is going to be your movement. Okay, right. Now this is going to be your what is called as the Z. Okay, and this is going to be what is called as your X. Please understand carefully. Okay, in turning, the work part is rotating. Okay, in turning, we are having only 2 axes. One is called as X axis, that is called as Z axis. Okay, what X axis is all about? X axis will gives you what is called as the diameter. Okay, X axis is going to gives you what is called as the diameter. Okay, and y axis, z axis is going to give the length of the work part. Okay, now in lathe we have only 2 axes, which is the x and z. Okay, right. Then we have what is called as the milling. What is milling? We have, just observe. Okay, if this is going to be the work part. Okay, just assume this is the work part. Okay, right. Okay, right. Now this movement, okay, right and left, Okay, this is called as X. Please understand, this is called as X. Okay, this is applicable to milling. Okay, remember, you know the basic concept that turning is going to be a cylindrical work parts, and the milling is going to be carried out on a prismatic work parts, or a cubical type of the work part. Okay, now this is called as X movement. That means what? If I am the operator here, let's assume I am the operator here. Okay, right? Now, if I am the operator, okay, right? Assume the operator here. To the left of the operator and to the right of the operator is called as X. Then like this, okay, towards the operator and away from the operator, okay, is what is called as Y. Okay, that is X and Y is called as the table movement. Okay, X and Y is called as the table movement. Please understand carefully. Okay, then what is Z? We have what is called as a spindle here, and this is your what is called as your the milling cutter. Now the movement of milling cutter, okay, that is the downward movement of the milling cutter and upward movement of the milling cutter is what is called as Z. Okay, now in case of milling, we have three axes which are X and Y associated with that of the table movement, and one more movement is called as the Z, which is nothing but the milling cutter movement. Okay, that is a three-axis machine. Now you understand that two axis is going to be a lathe and three axis is going to be milling. Then we have some more axes which has come into picture, which are called as four axis and what is called as five axis. What is this four axis CNC machine? Let's take one example of four axis. Okay, in four axis we have what is called as X, Y, Z. Now you know at this point of time what is X, what is Y, and what is Z. Okay, then we have what is called as A, B, and C like this. What is A, B, C? Remember, A, B, C are nothing but the rotational movement. That means I will now in this case the spindle is going to move only in vertical direction. Okay, now I will rotate this. Okay, I will give some rotary movement to the spindle. If I give some rotary axis to the spindle, the inclination of the spindle head is what is called as A. Okay, right. So B is also what? The work table inclination. I'm going to give an inclination to the work table. Okay, so the work table is going to be flat. I will try to rotate by certain angle. Now what you are trying to do is all this rotational movement is going to help in machining a curvilinear profile. Okay, so as now if you observe you might have observed a word called as, or listen to a word called as aerofoil structure. Okay, in aerofoil structure you need what? You need a very smooth finish. Okay, so it is not possible to reach to a particular point. Therefore, there is something called as the angular movements has been given. So y A and B is nothing but the rotations that you are given. Okay, now that is nothing but the angular movement. Okay, now more the number of axes. Remember, more the number of axes, the accuracy with which you are going to machine is going to be higher and higher. Okay, now that is what is the case. Okay, right. This is about the number of axes. Last one is called as based on the input power supply. What type of input power supply you are going to give? Okay, so you may run the machine by using electrical power or hydraulic power, pneumatic power, or hybrid power. Hybrid power is nothing but combination of the above, maybe electrical hydraulic, electrical pneumatic, hydraulic pneumatic, hydraulic electric. Okay, now generally we will be going with what is called the electrical powered CNC machine. Okay, so this is just a general understanding. Okay, so these are the four different types. Okay, four different types of four different categories. Okay, of classification of CNC machine. One based on the feedback control system, which is open loop control system and closed loop control system. Second one is based on the motion, that is called a PTP motion, straight cut motion, and contouring motion. Third one is based on the number of axes, 2-axis CNC machine, 3-axis, 4-axis, and 5-axis CNC machine. Fourth one is based on the input power supply, which is electrically powered or hydraulically powered or pneumatically powered or combination of the above three. So this is important one, that is a classification of CNC system. Okay, right. Now we just list down. Next we'll just go with the advantages of CNC. Okay, so these are the general advantages that I have listed here. Okay, so higher flexibility. Now you can able to produce different kinds of the work parts. Okay, different let me say different designs of the work parts can be produced. Okay, that is what is the flexibility all about. Then increased productivity. Okay, increased productivity, that means faster way of production. Okay, and quality is ensured because the human labors are not present here, and mostly the movement is going to be done by an automated means. Therefore, the quality is going to be assured. Okay, so non-productive time is reduced. So handling of the work part by a human labor is going to be reduced. Therefore, you'll be reduced with what is called as your TNO and what is called as TSU. Okay, so TNO and TSU is going to be reduced. Okay, right. Then accuracy is going to be better. Okay, definitely good accuracy, and repeatability is going to be assured. Repeatability is something, but if you are turning a job of 20 mm, every time you can able to turn a job to 20 mm without any of the difficulty. Okay, then as higher productivity, and you can also say it's a lesser scrap rate. Okay, that means no loss is going to be present. Okay, inspection requirements are reduced. Okay, that means as it is accurate and repeatable. Okay, as the work parts are going to be accurate, then there is no much requirement for you to go for inspection. Okay, then more complex part geometries are possible. This is a very good major advantage of your CNC, wherein you can able to machine the complex geometries. Okay, by having what is called as the 5-axis CNC machine, you can able to machine anything and everything. Okay, so that is very important. Means reachability of the tool to the work part is going to be largely enhanced. Okay, right. Engineering changes are easier to make. Engineering changes is nothing but specifications. Okay, that means you are having something like this. Okay, you can easily make it like this, and you can produce the operation. That means what? Now from year to year there is some change in the fillet. Okay, so without much of the difficulty you can able to achieve these changes. Okay, simpler fixture, shorter lead time. Shorter lead time is something but production time is going to be faster. Then reduced part inventory and less floor space, and operator skill level requires are reduced, and automated material handling. Okay, some of the all the possible advantages that I have listed here. Okay, all the possible advantages I have listed here. Okay, so which are going to be important. Okay, maybe some maybe for short notes you may get this. Okay, right. Then disadvantages are few. Okay, obviously higher investment. Okay, higher maintenance, and skilled labor requirement is going to be different. Okay, right. So this is with respect to the basic understanding of what is called as the CNC. Okay, so this is the first part of the chapter about what do you mean by CNC, what are the features of CNC, what are the classification of CNC, and components of CNC, and advantages and disadvantages of CNC. Okay, now this is the first part. Okay, right. Then next is going to be what is called as CNC programming. Okay. Now, if you observe the case of CNC programming, so we have two different types of CNC programming which are going to be present. One is called as manual part programming. Okay, that is called MPP. Please remember, manual part programming is nothing but MPP. Then second one is called as computer assisted part programming. Okay, right. Now the one what we are going to do is called as manual part programming. Means we are going to write the program and we are going to input to the MCU. Okay, so that is called as the case of manual part programming. Okay, computer assisted part programming. Okay, is a case wherein the computer itself is going to generate the program if you are going to give a part shape to it. Okay, if you give a part shape to it, computer itself is going to generate the program. Okay, so from the student perspective, what is important is to understand the manual part programming and not the computer assisted part programming. Okay, right. Now before we understand what is that we are going to do in manual part programming, okay, now we'll try to understand what are the different steps involved. Okay, different steps involved in the development of a part program. Okay, so what are the various requirements? Okay, now so you can able to understand. First and the foremost is now you will be having a work part to be produced. Okay, so in order to produce the work part, first what is required is to study the component drawing. Okay, first you are going to study the component drawing. From where are you going to get this? You are going to get this from what is called as a product design team. Okay, from the product design. Okay, you are going to get. Okay, so you have what is called as the product design team. Okay, so from the product design, you are going to get what is called as the component drawing. Once you get this component drawing, okay, then you are going to analyze this component drawing. So what for you are going to analyze the component drawing? What is the shape of the work part? It is very important. What is the shape of the work part? Okay. Then what is the tolerance that is given? What is surface finish given? What type of operation that you need to carry out? Okay, all that you are going to observe by using the component drawing. once you have studied the component drawing, okay, once you have studied the component drawing, then you are going to identify the machine tool. Okay, now next thing is identification of the machine tool. Okay, now in order to identify the machine tool, I have in my database, I am having a machine tool database. Okay, from the machine tool database, I will search the machine tool database so that I can able to choose the required machine tool. Okay, generally if I just want to make a mention, now the component drawing, okay, after studying the component drawing, okay, what you observed is you observe which two things generally. Okay, one is a cylindrical work parts. Okay, the work part what you observed is a cylindrical work part. Okay, in order to do the cylindrical work part, the type of machine tool that you are going to choose is CNC turning machine. Okay, right. Or otherwise, the work part what you observed is something like this. Okay, so that is nothing but your what? The cylindrical work. Sorry, what is that? The prismatic work parts. Okay, now this is something like this. Okay, so it's a prismatic work parts. Okay, so prismatic is something but box-like work parts, or it's also called as the cubical work parts. Okay, now in order to do the operation on this, you require what? You require the CNC machining center. Okay, broadly, we have two things. One is CNC turning center and CNC machining center. CNC turning centers are related to the turning related operation. CNC machining center is related to the milling related operations. Okay, right. Now, after you have identified the machine tool, okay, after you have identified the machine tool, next is engage what is called as selection of the cutting tools. Okay, so what type of cutting tools are going to be required? Okay, so again, you go through with the cutting tool database or the machine tool database. Okay, in order to know the different types of the cutting tools. Okay, then next is determine machining parameters. Okay, what is machining parameter? Machining parameters is nothing but what? So very important: speed, okay, feed, and depth of cut. Okay, so these three are generally called as the machining parameter for a machining process. Okay, what should be the speed of the operation? What should be the feed of the operation? What should be the depth of cut? Depending upon the type of operation, you are going to choose these three different parameters. Okay, you know, turning the requirement of speed, feed, and depth of cut for turning operation is entirely different from the drilling operation. Okay, drilling requires largely lesser amount of speed, lesser amount of feed, lesser amount of depth of cut. Okay, on the contrary, the turning requires more speed, okay, more feed, and greater depth of cut so that you can remove more amount of work parts. Okay, depending upon the type of operation. Okay, just remember, depending upon the type of operation. Okay, so you are going to choose the machining parameters. Okay, that is very important. Okay, right. Once you have done the machining parameters, the next is prepare job and tool setup plans. That means what? Okay, you are going to prepare a setup. Okay, you are going to prepare your machine tool, okay, to carry out the operation. Okay, then write the part program. Okay, now you know what are the movements which are going to be present. Based on the movements, you are going to write the part program. Okay, then you are going to test the part program. Okay, remember, you are not going to directly send this over here. Okay, so this is not allowed. Okay, remember, this is not allowed. Okay, after writing the part program, you are not going to send the part program to the machine. Rather, you are going to test the part program. Okay, now you are here, in this case you are testing the part program. Okay, if the program is okay, if the dry run is okay, then you send that program to machine control unit. Okay, send that program to machine control unit. Then in turn, machine control unit will give the instruction to the machine tool to carry out the operation. Okay, once the operation has been done, then you inspect the part. Okay, so that is the positive side. On the other side, observe that there is some observation, some problems that you have observed during the testing. That means what? There might be a large number of the hit is going to occur. Okay, now that is, you can observe the dry run. By observing the dry run, you can observe, is there any loopholes or is there any problems during the machining? If that problem has occurred, that may be due to larger speed. You might have considered larger speed, or you might have given a larger depth of cut, by which problems might be occurring. So again, go back and check the machining parameters and redefine the machining parameters and proceed further. Okay, so after everything is completed, document the program. Okay, now these are the steps, the larger amount of the steps which are going to be involved in development of a part program. Okay, so once you have done this, okay, once you have done this, next is going to be, we'll go to the actual CNC manual part programming. Okay, right. Now First thing, okay. So in case of CNC manual part programming, first you need to what you need to understand is the coordinate system. What type of coordinate system that you are going to use? Remember, what we are going to use is what is called as the Cartesian coordinate system. Okay. So the type of coordinate system what you are going to use is called as a Cartesian coordinate system. So in case of Cartesian coordinate system, you are going to use the X, Y, and Z. Okay. Now remember, in case of a lathe, okay, in case of a lathe, we have two different types of the axes which are going to be present. One is what is called as X, other is what is called as Z. Okay, as I told earlier, Z is nothing but, okay, now if you observe, this is going to be a turned operation, or the turned work part, and this is going to be your 0 point. Okay, right. The X indicate, now this is the X. Okay, sorry, this is your Z, and this is your what is called as X. Okay, right. Now this is positive. Okay, positive. Okay, right. Now if you are moving towards this, the tool is going to move towards this. Z indicates what is called as this, because Z indicates what is called as the length of the work part. Okay, please understand. Z indicates the length of the work part. Okay, this one. Okay, so length of the work part is going to be Z, and X indicates, okay, X indicates what is called as the diameter of the work parts. Okay, now this is called as your X. Okay, so these are the two coordinates. Generally in the lathe we are going to use only two coordinates, which is called as X movement and Z movement. Z indicates the length and X indicates the diameter. Okay, so that is the first thing. Okay, then now when you are going to move from, this is the last topic that I just like to take. Okay, so once you are going to move the CNC coordinate system, okay, you can move in what way, how the measurements are going to be taken. Okay, so there are two different coordinate systems are going to be present. One is called as the absolute coordinate system, other is called as the incremental coordinate system. Okay, remember, okay, it's very, very important. Okay, so based on this only, all the programs are going to be made. Okay, so what is absolute coordinate system? Okay, in case of absolute coordinate system, all the distances, okay, all the distances are going to be measured, okay, from the fixed origin. Let's observe this. Okay, so this is your fixed origin, 0, 0. Okay, the distances of point number 1, point number 2, point number 3 is going to be measured from this point only. Okay, right. So this is this distance. Okay, then if I want to measure the distance, second point distance, the measurement is going to be from the fixed origin only. Okay, right. If I want to measure the third dimension, the measurement is going to happen from this fixed point. Okay, this is also called as the parallel dimensioning. It is also called as the parallel dimensioning, or it is a parallel type of method. That is an absolute coordinate system, that is location defined relative to the origin of axis system. Okay, in case of incremental coordinate system, location defined relative to the previous position. Means what? For the first point, okay, now let's say, let me take again. Okay, this is the coordinate number 1. If it is incremental, now the measurement is going to be taken. I'm only taking about only x-axis measurement. Okay, so this is the coordinate of 1. Okay, this is the coordinate of 1 x moment. Okay, then I want to go to this point. Okay, now for the, yes, location 2 is going to be measured. Location 2 is going to be measured from the previous position. Okay, for 2, what is the previous one? Previous one is 1. Now the 2 dimension is going to be measured from this point. Okay, please understand. Okay, this point. Okay, if there is going to be a third one, okay, so the dimension of the third is going to be measured from the previous point. Okay, that means it is called as, this is 2 and this is 3. Okay, now here it is, this is 1, this is 2, and this is 3. Okay, so that is the difference. Okay, now can able to understand, okay, by using this particular example. Okay, now just observe here. Now this is the current position. Okay, so 20, 20 is the current position. Okay, now if now I want to move from this point to this point. Okay, right. So this is the current position. The tool has to move from this point to this point. Okay, now the tool has to move from here to here 20, from here to here it is 30. Okay, now if it is absolute coordinate system, what is the location of this tool is important. If it is an absolute coordinate system, the position of this is going to be measured from 0, 0. That means how much it is. Now from here to here is how much? From here to here it is going to be 40 mm. Okay, axis, x-axis, and from here to, that is y-axis, it is going to be, what is this is going to be a 50. Okay, therefore now this is called as 40 comma 50. Okay, 40 comma 50 is going to be what is your absolute positioning. Okay, so x is equal to 40, y is equal to 50 is an absolute positioning. Similarly, if it is going to be incremental positioning, okay, if it is a incremental positioning, the movement is going to be what? This is going to be based on this point. Okay, from here to here it is 20, right? From here to here it is going to be 30. Therefore, x is equal to 20, y is equal to 30. Okay, so this is an incremental position. Very simple. Absolute origin is the reference. Incremental previous point is the reference. Okay, so this is the one which is very commonly used in case of your the absolute and incremental positioning system. Okay, right. So I'll stop at this point. Okay. So next we'll start tomorrow. We'll start with the program. Okay. Now this is how the program is going to be there. So please participate in the program. This is very important from the perspective of your examination or from the next concept of your work also. So we'll take up the programming in the next class. Okay. So by the time you please all of you enter your USA number in the chat box. Okay, enter your USA number in the chat box. Okay, okay, and you can leave for the class. Okay, please enter your USN, and tomorrow or the next class. Okay, I just want you to join for the program. Okay, don't miss. Okay, don't miss the classes. Okay, so yeah, thank you very much.